So hi Year 10, today we're going to be looking at how certain types of electromagnetic waves are produced. We're going to be looking at radio waves, we're going to be looking at visible light, and we're also going to be looking at gamma rays. So let's take these one at a time. Let's start with radio waves. So radio waves are produced whenever electrons oscillate in a metal conductor. So if this little red dot is an electron, when that electron oscillates, it basically means it moves back and forth like that. Now it's important that this thing that it oscillates inside is made of metal, because then it's got lots of free electrons and all the electrons in there can do the same thing. And this would be called an antenna. And in fact it's this thing here that is going to transmit the radio waves. So you could call this the transmitter. Now somewhere over here there's going to be somebody that wants to listen to the radio. So this might be connected to their radio set. Okay, so there's the volume and that's the tuning dial that tunes the radio station. So what happens when this electron, and in fact all the electrons in the antenna, oscillate up and down? Well, as these things oscillate up and down, what happens is they create an electromagnetic wave. So they create an electromagnetic wave, and it's called a radio wave. Okay, and that electromagnetic wave, you've got to remember, goes in all directions. Now, if this is your radio and you've got the radio turned on, what's going to happen when this electromagnetic wave reaches your aerial? So your aerial is the thing that picks up these radio waves. Well, what happens is, if there's an electron inside the aerial, and don't forget there'll be very many electrons in there because aerials are made of metal, then as this radio wave moves past your aerial, it causes all of these electrons to move up and down. And the great thing about this is that all these electrons move up and down in exactly the same way that these electrons did. And so, whatever signal you put in, so it could be some music, okay? So whatever signal you put into your antenna which causes this oscillation, you're going to get the same oscillation, you're going to get the same signal that goes into your radio. So whatever you put in, you will get out, and so that means then that you're going to get this music playing out of the speaker of your radio. So essentially radio waves are caused by oscillations of electrons in an antenna that create these electromagnetic waves that we refer to as radio waves, and those electromagnetic waves then cause electrons in an aerial to oscillate, which can then be decoded by your radio or by your TV as well. TV works the same way, it's just that the information's turned into a picture, not into sound, and so the radio or the TV decodes the information, and in this case it turns it into the same signal that was put in the first place. So that's radio waves. The next thing that I want to speak to you about is visible light. Okay, so let this be the nucleus, okay, of an atom. I've not really drawn it in very much detail because we don't really care about the nucleus for this discussion. But what we do care about are the shells of electrons. That's terrible. But what we do care about are the shells of electrons that live around the nucleus. Now sometimes electrons can be given a little boost of energy, and that can happen in any number of different ways, but we don't need to worry about how that happens. But what happens when an electron, let's say this electron here, if that electron gets given a little boost of energy, what can happen is it can jump up to this shell, So it goes to a higher shell. It's almost like if you were to give a book on a bookshelf a little bit more energy, well, what you could actually do is you could lift it to a higher shelf on the bookshelf, and then it would sit higher than it normally sits because it's got more energy. So you can sometimes get electrons that live up here where they're not really meant to, and that's because they've been given extra energy. Okay, but they can't live there forever. So let's imagine that this electron here has got too much energy because it's been given that little boost. Well, sooner or later that electron has to fall back down to live where it normally lives, where it should live. Now, if you see this situation over here, to move the electron higher, we had to put energy in to the atom. But when this happens, well, can you guess what's going to happen? The energy that the electron loses by falling back down, well, we have to get energy out. And the way that the atom releases energy, the way that the atom transfers energy to the surroundings, is in the form of visible light. So an electromagnetic wave is emitted, and it will be in the visible part of the spectrum. So that's how visible light is formed. What about gamma rays? Well, gamma rays, or gamma radiation as it's sometimes called, is a very similar story to how light is produced. However, we're not bothered about electrons when we're dealing with gamma rays. What we're actually talking about is the nucleus of the atom. So let's draw a really simple nucleus. Okay, so there's protons and neutrons all clumped together, like so. Now, sometimes the nucleus of an atom can have a little bit too much energy. It can be sort of like wibbling and wobbling, a little bit like a jelly. So imagine if you made a jelly and you took a jelly out of the fridge and you poked the jelly. Well, the jelly's going to start wobbling on the plate. It's got lots of energy. Well, sooner or later the jelly will stop wobbling and it will have lost all that energy. And it's kind of like the same thing with the nucleus, except with the nucleus what happens is it doesn't slowly go from wobbling to not wobbling. It goes from wobbling to suddenly not wobbling at all. Okay, so it suddenly goes into this state here where it's not wobbling at all. Okay, so here we've got too much energy. Now, can you see the similarity between this situation and this situation here? Okay, here the atom, the electrons have got too much energy. Here the nucleus has got too much energy. And in this situation here, the electron loses that energy. And it's the same thing here. The nucleus loses that energy. And how did the atom transfer that energy to the surroundings? Well, it transferred it in the form of a wave, an electromagnetic wave. Over here, this electromagnetic wave was in the part of the spectrum where we find visible light. And over here, when this happens, this energy is transferred to the surroundings in a wave, an electromagnetic wave, but this time it's in the gamma part of the electromagnetic spectrum. So let's not forget, gamma is extremely high frequency, very, very short wavelength, and as a consequence it's also got very, very high energy. So gamma is a type of radiation that we call ionizing radiation. So these two situations are really similar to each other. Essentially, you've got too much energy, the energy is released, in the form of an electromagnetic wave. So I'm going to put EM for electromagnetic, in the form of an electromagnetic wave. So they're the similarities between these two situations. What about the differences? Well, the differences are simply that so these are similarities, these are differences. The differences are, for visible light, it's electrons that have got too much energy, whereas for gamma, it's actually the nucleus of an atom that has got too much energy.